I guess I'll introduce myself. uh, so I'm doing the demo tonight, and the subject is using vacuum systems for vacuum chucking and remounting. I have found that I use my vacuum system uh, almost every time I turn. I mean, I use it for a variety of applications, and and one of the one of the ways I've found that you can do this, it has to be set up and convenient to use. And if it is, that you'll find all sorts of uses for it that you haven't thought about before. And so the purpose tonight is to take some of the mystery out of setting up a system and how you use the system, and for those that are already using the system, maybe some ideas on how to use it more efficiently. So in order to facilitate this, I have I've broken it into two videos. It's pre-recorded. First one is about 35 minutes. I'm going to go ahead and start it. If you have questions, go ahead and put them in the chat. And if there's something I can answer right away, I'll go ahead and just pause the video and try to answer it. But if it's something that can wait until the end of the first section, we'll go ahead and answer questions then, and also answer questions at the end. I am in my shop and set up, so if we need to show something, if you want more detail or something on something you've seen in the video, just wait until the break, and we'll pick up the camera, and I have stuff laid out on the bench. We can show it to you. So with that, we will go ahead, if I can make all this work.
Where's the background music we paid for?
Yeah, it's coming.
Hello, I'm Steve Criscenzo and welcome to my shop. Today we're going to talk about rechucking systems, how to finish a piece that to get that last part off the bottom that needs to be finished, or mainly on bowls, but it can be used for other pieces as well. We're going to talk about various methods, but really that we're going to focus on vacuum chucking because that's really one of the more complicated systems to get set up, but we will talk about the other options. We'd like to start with just a quick safety minute though, that when you're working with any rechucking method, you really don't have the security of whatever holding method you use when you're doing the primary part of your work. And therefore the holding system is not going to be, whether it's a jam chuck or a vacuum chuck, whatever system you're using, it's not going to be as secure as the original method. So you have to take that into account with the speed that you're working with, the aggressiveness of your cuts, the direction of your cuts, and all that needs to be considered as you finish the work. So what we're going to cover today is we're going to talk about some the variations in the systems. We're going to talk about maintenance, and particularly with the vacuum chucks, how to set up a vacuum chuck system, what you need to do to maintain it, the various attachment methods, the various hardware you're going to need, and we're going to talk about generating or creating vacuum chucks and how to make them and the various applications you can use them for. So with that, let's just talk about some of the rechucking methods you can use. A lot of people, when they make a bowl, they get to this point where they have a finished bowl, and if you've used a recess or a tenon, whatever your choice is, that a lot of times we'll see that this is what some people consider a finished bowl. And you'll notice that when people, particularly in art markets and stuff, when people look at your work, one of the first things they do is they'll turn it over like this. And in my opinion, that this isn't a finished bowl, because you can still see the attachment method on there. You got sharp corners on it, and often you'll see remnants of the chuck that was in there when you had it mounted for turning. So you need some means to, after you've turned the outside, turned the inside, and held this with a chuck, how do you come back now when it's all finished and hold this to get this bottom finished. I prefer to have a bottom that different people have different methods. The bottoms of my bowls, I tend to just put a very subtle foot. It's got to be slightly concave in there so it'll rest on the table, but it is a finished piece. And again, there's no visible evidence of how you are holding this on the lathe. The center part's gone. You can see it on some of these other ones. Again, just sometimes you can have a little bit more pronounced foot on there, but again, the chucking method that was on there is gone, and to me that just creates a much more pleasing piece than if you have something like this where you're still showing the where the chuck held onto it. So how do you get, when you have this finished piece on here, how do you get to the point where you can turn that bottom off? And what you need to do is some means to hold it back onto the lathe. So there's various methods you can use. It starts with the simplest, is just using some sort of jam chuck. And this is just a piece of ash that I turned. It's got a convex head on it. And on this piece I have this threaded so it'll thread onto my spindle, but you could just mount this into a chuck instead. And so this just threads on. I'm not going to put it all the way on, but and then what you typically do is you would take some kind of foam pad and stick it on there, put this on here, and then you would bring your tailstock up and hold that on there. Right now, the advantage of this, and let me just get another piece that has a center point on it. So I've maintained the center point from my rough turning. You just put it on here, and that's, at this point you could go ahead and finish this. Now, the disadvantage is that you need the tailstock to hold this on here. So you can't take this all off, but you can get down to the point where you just have a small nub left on there, and then you can just sand that nub off when you get to it. But that's the simplest method. It requires, other than a scrap of wood, it requires no other equipment. It's cheap, it's simple, and the downside is you just need to get this to the point where you're going to just sand this little piece off. Another advantage of this is you can use it with an irregular shaped piece. So if you have a natural edge bowl or something like that, you can actually put this on here. It's not relying on the rim of the bowl in order to hold it onto the lathe. So that's the most basic method. And again, you can use any kind of foam pad on here. This is just drawer liner material. You can use. I tend to save a lot of my foam packing material. That also works on there. A mouse pad works. An old mouse pad works great because it has a little bit of grip to it. So that's the simplest method. Another method is often used by Ashley Harwood is the master of this. I rarely use it, so I'm not as good. But Ashley is very, very proficient in using a jam chuck, where she will take this, and this is just a block of maple held on with a chuck. And if you do this right, this is just a small bowl that just needs the foot turned off on it. And if you do this right, you can get a snap fit on there. And yesterday when I did this, it did snap fit in there. Things have changed overnight, but it'll hold on there, and she could just snap it in. Or if you're worried about hold, you can actually put your tailstock up and hold it on there for a little bit more security, or even use tape on here. So it's on there it fits there pretty well, and you can go ahead and finish that foot. And the advantage is that, particularly if you put a couple pieces of tape on here to hold it, that you can actually get the whole bottom off. You don't have to worry about that, sanding that little nub off when you're finished. So so that's a method. And again, if you want to see how to do this, I can't demonstrate it because I'm just not nearly as proficient as some people like Ashley are. But there's a couple of YouTubes on video with her doing this, and she gets this pop fit on there that holds it on very securely. All right, so that's one of the downsides of this. It is simple. It doesn't require a lot of materials. One of the downsides is that if you're turning a good-sized bowl, that you need a piece of stock that's equal to the diameter of your bowl in order to make this work. So that's a lot of material to have around if you're going to do it. So and then the other thing is you need a consistent rim across the top that you can't do within a regular shaped piece or a natural edge piece if you're going to do it. But it will hold it securely in there, and again, put a little bit of tape on there. And if you're careful with it, again, you just have to be careful when you're doing this that you don't cut too aggressively. It will hold on there just fine, and you can make it work. So the next method is jumbo jaws. These jaws fit onto these are made by One Way, these particular ones. This is on a Stronghold chuck. Here's another one that's on a Talon chuck. Two different sizes. And these thread on. And again, you would you just the stoppers to hold your bowl. You bring this in, and you use your chuck to hold it on there. And it gives you free reign to do. You can do the total finishing on this, and it's very secure if used with the proper precautions. And they do have some speed limitations you need to look at. I think on this one, this says 1,000 RPM. I think the small one's 500. But you do have to be careful with these. I find them a little bit disconcerting to use because you got this, you could be working on something this size. You got this big rim spinning around it up to 1,000 RPM, and that can do some damage on your fingers if you're not careful. So it does require some care. Personally, I wouldn't run this more than about 500 RPM. Couple disadvantages to this. I mean, I started with these, and I have the two sets, and I used them for years before I got my vacuum system. Since I got my vacuum system, I really don't use them. But one of the disadvantages is the cost. They're about, I think the small ones are about $100, and these ones are about $140 or $50 just for the jaws, not including the chuck. There's the time that it takes to transfer jaws on the chuck, which again, if you're trying to do production work, that is a bit of a disadvantage unless you have chucks you can dedicate to it. And you're limited to, again, a straight edge bowl. If you were to do either a natural edge, obviously you can't hold that on there. There's no way to hold that on there, or I do some of these lens-shaped pieces that don't really have a flat surface on them to go on there. Again, they're not going to be able to mount on there. So, but they are a very secure. It's a good, reliable method to use. Again, that you can put different size knobs. You can put higher knobs on here if you need to. If you have something that has a broader rim on it, it's a pretty good method. Similar to the jumbo jaws in holding method is the Longworth Chuck. Uses a spiral instead of turning it with, it doesn't require a chuck. It uses a spiral method on your knobs, and it will kind of turn right in. And so again, similar holding power to this, and it has similar disadvantages and advantages to this. One of the disadvantages is the cost. If you're going to buy one, they're $150 to $200 depending upon the size. Although a lot of people, including some of our members, have made them, so they're not that difficult to make. With a little bit of router work, you can make your own and put it on. So that's the Longworth Chuck and the jumbo jaws. And finally, the last method we're going to talk about today, and the one we're going to spend the most time on, is the vacuum system. So a vacuum system uses negative air pressure to hold the work onto the lathe. And depending upon the size of the piece and the vacuum that you have, it will hold with several hundred pounds of work. With several hundred pounds of force to hold your piece onto the chuck. So there's a variety of vacuum chucks. We're going to talk more about chucks in a little bit, but essentially you put a chuck that has some kind of gasket on the front of it, and then you take your piece and put it on, and you apply a vacuum through your spindle, and that piece will be held on there, again depending upon the size of the chuck, with a fair as much force as that is necessary to finish the bottom. The advantage is that you have full control over the bottom. You don't need a tailstock. It's good to use the tailstock when you get it centered and when you're starting out, but you can, when you're to the point where you're going to finish the piece, you can get it and remove the tailstock. If you were to go with another advantage is that you're not restricted by size. So if you were to have a large piece, in this case this is about a 20 maybe 18-inch platter, bigger than the jumbo jaws, bigger than it would take on the Longworth, and you certainly wouldn't want to try to put this in a jam chuck. So you can take this and hold it on here, and it'll hold on fine. Again, you're not limited by the size of the piece. So you can do irregular shaped pieces. The way I finish, when I create these lens shaped pieces, I have a glue block on these to start it out. I do one surface, and you'll see there's no place to hold this to turn the back side. So I turn the entire back side of this piece using the vacuum chuck. I use my tailstock initially to get the rough shape, except for the very center. But when I remove the tailstock, that is held on there secure enough to go through the rest of the turning and finishing process. So there are times when this provides holding power that there's really no other way to do, in my view. Since I've started using the vacuum system, I rarely use any other kind of holding method, because there's very few pieces I've found that this doesn't, I can't adapt some means to make this work. You can use a variety of different chucks, either homemade or store-bought, and therefore you can use chucks that you can adapt to whatever system you're using or the shape of the piece. And again, we're going to talk about how to make some homemade vacuum chucks here later on, but I was doing some pieces, some vase shaped pieces that had a long taper on them, and I actually made this chuck to have those fit right inside here, the head of those, instead of holding on the end in it. And so you can, by making these out of PVC, you can manipulate the shape of these to whatever shape that you need to be turned. So the disadvantage of the vacuum system is that, one of the disadvantages is that it is expensive. they and they require some setup. So you need a vacuum pump, and we're going to talk about the components you need, but it does require a separate setup. The advantage is that once you have it and your system is set up, it's so quick and easy to use. In my system, I have a vacuum pump ready to go. I have a quick connect that connects to the lathe. The chucks are right behind me, and when I get to the point where I need to finish something, it's a matter of minutes till I'm set up, ready to go on this. So just an idea of cost, probably one of the best places to buy a vacuum system is there's a website, a company called Frugal Vacuum Chucks, and they sell a complete package including the pump and all the fittings for about $315 to about $325. It does require you to do some of the fabrication yourself. It doesn't include any specific chucks. You have to make the chucks yourself, but it gives you the materials to make the chucks. So that's kind of an entry point, and we're going to talk about. The heart of those systems is the chuck. The vacuum pump, and what comes with that system is a very good vacuum pump. So what do you need to create to set up a vacuum system? Well, it starts out with the pump, the vacuum pump, and like I said, you need to have a very it's the heart of the system. You do not want a pump that's going to let go in the middle of holding a piece on your lathe, and it could cause not only injury to you, but it could damage a piece that you spent a lot of time on, because it is holding the very last step in the process. So you want a good, reliable pump. Again, we'll talk about various types of pumps in a minute, but you want a pump that's and in my view, it's better to have a pump that's set up and dedicated to your vacuum system. As an alternative to a vacuum pump, a number of people use a Venturi vacuum generator that is hooked up. That uses compressed air from your compressor to create the vacuum using the Venturi process. They work. They are a little bit limited in the volume of air that they can vacuum that they can move. So if you're doing a very porous piece with some punky burl or whatever it is that you're trying to hold, they can be somewhat limiting with the Venturi systems, but they work. It's a very they're about $80 or $90, so it's a fairly economical alternative to buying a $250 pump. The next piece you need some means to get the vacuum through your headstock. And that requires some form of adapter. And there's two methods really actually three methods you can use. Probably the simplest and most universal is this system that I've had for a number of years. I believe this was made by Holdfast. Craft Supply sells something similar to this right now. I think they changed this piece. It's a sealed bearing on this end with a quick adapter on it, and then just a piece that fits in here and holds into this end of your headstock. The other end feeds into your tailstock, and you can just you just thread it on and connect your hose to the end. Very reliable. And what's the beauty of this is it can be used on any lathe just by changing the length of this rod. Back when I had my Powermatic, I had a different, and this is just lamp rod, so you can go to any home center and buy a 3-foot piece of lamp rod, cut it to the length you need, and it adapts to the lathe very easily. So again, very, very easy method. If you have multiple lathes in your shop, this is a good way to do it, because you can adapt it to any lathe. You can also make your own, and again, with the kit that comes from the Frugal Vacuum Chuck, they have the plans to make that system, another system that will fit into your hand wheel. Most hand wheels have, well, all hand wheels should have a hole through them, and they make a system. And the important thing is, if you're going to make your own adapter, make sure you do something with sealed bearings, because if you don't use sealed bearings, you'll lose all your vacuum through the bearings, so you don't want to do that. And then the third way to do it is to just buy an adapter, and this is very similar to what you would make if you're making a homemade one. This one is made by Robust for this lathe, and again, it's sealed bearings. It's got 2 O-rings on it, and it simply fits into the end of the hand wheel, and allows you to hook your vacuum pump up to it. So, so those are the various methods for attaching, for getting the vacuum through the headstock and into your vacuum chuck. The next thing you need is various fittings and hoses. Again, on my system, it's going to be hard to show this really, but I have the pump mounted up above my lathe, and that just was a convenient place to put it out of the way. And again, it's a pump that's dedicated to vacuum chucking. I have a hose that comes down from the pump, and I have a vacuum gauge, which is another component that you have to have, because you need to know where you stand, you know, as far as whether you have sufficient vacuum coming through to hold your piece. I have a bleed valve on here, and what this does is there are times when you're dealing with a very thin-walled piece that the vacuum will actually pull enough that it can break your work, or you can actually watch the bottom of your piece being distorted as you apply the vacuum. So there's times when you need to bleed a little bit of vacuum from this. This isn't required, but again, if you're dealing with very thin-walled pieces, I have had pieces break when the vacuum's applied, particularly with the larger chuck. So this just is a needle valve, and it allows you to bleed off pressure from, or vacuum from, your system. I have a switch right here that allows me to easily control the pump, and then from that another line that comes down, and I have a hose with a quick connect. This is just nylon hose that like you use for your refrigerator tubing, you know, your ice maker, and with a quick connect. And the quick connect would just fit right onto the adapter that goes into the back into the hand wheel. One word about quick connects. Quick connects are not really designed for vacuum. Some of them will work and some of them won't. But most quick connects are designed for compressed air, where the pressure of the air forces the connection to be sealed. I found that there are some quick connects that don't work with vacuum. So if you find one that doesn't, you just need to be aware of that it can cause leakage in your system. A couple other pieces of hardware, depending upon the pump. You may need an exhaust filter if you're using a pump that has oil in it. We'll talk about that when we break down some pumps later. But one thing that I don't see in many systems that I do recommend is putting a filter on your intake. And I just have you can buy these paper filters, and they're meant for vacuum systems, and they're a paper filter inside a canister. And after using my pump for about a year, I was doing some maintenance on it, and I took that filter off, and there was a fair amount of sawdust in that filter, and all that sawdust would end up in your pump if you're not using a pre-filter as it goes in. So it's just a good idea. It's not absolutely necessary. They're $10 or $15, and it's just a little protection for your pump. Again, usually a very expensive pump. So, and then that brings us back to vacuum chucks. Let me just move some stuff out of here. There's a lot of different a lot of different variations in vacuum chucks. Again, you have your choices between making your own or buying store-bought chucks. This is a one-way chuck, and this was about it's about $100, $135, I believe. It's a really heavy piece of cast aluminum. It comes you can put adapters in for whatever size you need, and it's a solid chuck. If I'm doing heavy work and you know, a heavy piece that's on here, this is the one I'm going to use because it's rock solid. One Way also makes a smaller one, and that you can use. So that's one method. And then, as I showed you before, an advantage of a vacuum system is that you can make your own chucks. And these are constructed out of just a block of wood, some PVC pipe, and I'll go through construction of one of these a little later in the demo. But this is, I tend to use, well, this one uses a small faceplate on there, and there is a gasket. I just used a foam gasket underneath that faceplate to try to create a better seal. But again, just a small faceplate that's on there that holds it on there that I leave permanently attached to it. You don't want to be messing around with taking the faceplate on and off, because once you get this thing centered and true, you want it to keep running like that. One of the disadvantages of using something that's wood is that it does move, has the potential to move a little bit on you. So if you are making your own, I recommend that you finish these with some kind of finish that will minimize the distortion of the wood base on these. So you don't want to have to true it up every time you use it. This one here, I tried using One Way sells these adapters for their chucks that allow the chucks to be used in a variety of different lathes. And I just bought one of these adapters and tried that, and actually this works very well, and it's just screwed in there with 3 screws. This one uses plywood for the base, 2 layers of 3/4 inch, and if you're going to use plywood, make sure you use lumber grade plywood that doesn't have any voids in it, and plywood's more stable, so it doesn't move, and it's actually stronger as well for the given diameter. And then I use caulk around the base of this after I glued it in to get a good seal on it. So those are, and again, there's a number of different ways. You can use a lot of different things. My only caution or concern with the homemade ones is they are not as rugged as something like the One Ways. So you just have to realize that's a homemade piece. You're stressing materials that aren't really designed to take that kind of load, and you just need to be cognizant of what loads you put on here and whether they're acceptable for doing it. And we'll talk more about the methods I use in order to strengthen these when we talk about how to make the chucks. So the other question that comes up often with these is what to use for gasket material. And there's a number of different things you can use. They're all very easy. My go-to is I use craft foam, and this is I buy this in packages from Michael's. It's sticky on the back. It's got self-adhesive on it, and it's cheap. I mean, it's a 9 by 12 sheet, I think, is about $1. So and by having it on there, you can change them as often as you need to. You don't have to worry about it being a problem. So that's one way. That is my go-to. And you can also put another layer on there if you need something. If you have slightly irregular surface, you have something that's not making a good seal, you can put a second layer on just to give you a little bit more cushion. So that's a good, reliable source for these. And so that's what's on here. And you can see this had multiple layers on it, and again, you'll see that it has tool marks and cuts on it, and but that's you can just do that as often as you need to and replace it whenever you need it. And the key is don't skimp on it. If it's looks like if it's nicked or chipped or just go ahead and replace it, because you're not going to get a good vacuum on it. There are a number of other sources that you can use for gasket material. You can save, packing material. I've used old mouse pads, the thin ones. Any closed cell foam should work. This is floor underlayment for floating floors, like laminated, like pergo and those types of things. I had a friend who was doing a floor, had this left over, and I probably have a 10-foot long piece that's 20 feet wide, or it's 20 foot long, 10 feet wide, and it'll last a lifetime. So that's what's on here. And if you use this, you just use spray adhesive, and you spray both the foam and your substrate, and you just wait till they tack up, and you just put it on there. And again, it's thinner. A lot of times I'll use multiple layers of this if I'm using it, but if I need something that really has to conform, sometimes this is a better choice than the foam that goes on here. So one of the beauties of the one-way system when you have to replace a gasket is that they make a nice little adapter to help you do it. So this is the gasket on this small one was worn out, and so I cut a foam donut. I sanded the old one off. I just hit it with 100 grit sandpaper. You just need to make it as clean as you can. You certainly don't want any irregularities in the surface. So if you do, just go ahead and clean it up. You can use Glue Gun or something like that to get the glue off if you need to. That's one of the advantages of using these self-stick foams rather than something that you have to use spray adhesive on, because it's much neater to use these. But the way this works is, I'm just going to hook up my system here. You just take the paper off. And get it about centered on there, and then one way gives you this nice little cap to turn your system on. And you pull it on, and then you just trim off the edges. But it just makes it, you get a good solid seal, but it just uses the vacuum to go ahead. You could, if you wanted, you could bring your tailstock up and hold it on there, and then you just trim this. You use this while it's on there to just trim the excess off, and you get a nice even surface on it. One caution about using the foam is that I stay away from black for some reason. I think whatever dye they use in the black, if your piece should slip at all on your chuck, sometimes the black will leave marks on there. So I use every color but black for this, and so it works well. So, and then I mentioned that if you have something that's kind of a bit of a rough surface on there, you can put another layer on there if you want, or you can even just take a piece of this, and a lot of times I'll just do this. I'll just cut a hole in the middle of this, and it doesn't even have to be glued on. You can take this and then just put something on there, and it'll hold it on there just fine. Again, it doesn't have to be glued, it just has to make a seal. So you can use multiple layers if you need. You have to be careful that it's not as secure, but it will hold it on there. If you have a surface that is slightly irregular, if some burls that aren't perfectly smooth. If you're doing something like ambrosia maple that may have holes in the wood, or you're doing something that is particularly, well, ambrosia maple is a good example. If you have a wormhole that's going through the side near where the chuck is or the base, sometimes you can switch to a smaller chuck in order to not have that in the bottom. But if you do, a piece of masking tape on the outside, as long as it's not going through the part that you have to cut, a piece of masking tape on the outside will often be enough that it will give you enough support on that that'll hold it, because the vacuum is pulling that tape in there. A dab of CA glue in a hole will also do the same thing if you can do that, if it's going through the base, for instance. So there are times where it's just not going to work, but the other thing I find that is you can actually use these chucks just to hold a piece on the lathe with your tailstock coming up, just if you're trying to true up the base before you return it, or to get your tenon or your recess fixed. They actually just make a good, just a holding method, instead of using the block like this. This already has the foam on it, and you can just use it as a compression to hold up there with the tailstock. So, with that, I think we'll take a pause here and see whether they have any questions, and we will proceed on with talking about vacuum pumps.
All right, you all still there?
Yeah, we're here.
Any questions?
Steve, do you use a reversing system to keep the bowl centered?
I'm not sure I understand.
So when you take the bowl is in its chuck,
Right.
it's 4-jaw chuck, and do you there's a device you can screw to your tailstock so that you can take the chuck with the bowl in it,
Right.
off the headstock and screw it onto the tailstock, and then put it up against your vacuum chuck.
I do not, John. I just leave a center mark in there from when I first mounted it on the lathe to do it, and I just recenter it with the tailstock doing that, and I've had fine luck doing that. I know what you're talking about. No, I don't use that.
Okay, thank you.
Dave,
Yeah.
I had an incident or situation one time where I was using a vacuum chuck. The bottom was thin, and I used
Hang on 1 second.
tailstock to hold it.
Norm, can you? There's a lot of background noise from somebody. Oh, thank you. All right, go
Mike,
ahead. I'm sorry.
Mike, you need to unmute now.
Better?
Yep, there you go.
Okay, when I was done with that, I made the mistake of turning the vacuum off and relieving the pressure before I took the tailstock off. And what happened to that to the inside that was pushed in, it pushed itself out, and with the tailstock there, it just made a nice big hole.
Yep, it can. So you just have to be careful if it's thin. I always make a point of I don't and I'm not sure I say this in there, but I always make sure that before I remove my tailstock, I have my lathe turned off, and I try to go through a process where I turn off the lathe and leave the pump on, but then remove my tailstock. But no, you can, if it's a thin bottom, you can actually, you can certainly distort the bottom enough to that you can punch through it if it's a very thin walled vessel. It's a good point. And along those lines, and you'll see a mistake at the end of this this video. The other thing is to make sure you turn off your lathe when you're finished, and the tailstock's not on it. When you're all done, to make sure you turn off your lathe before you turn off your vacuum pump. And and I know that, and I actually did it wrong at the end of this video, and I had to. But unfortunately, I was in the demo mode, and it wasn't going very fast, and it didn't go flying off. But it is important to keep that sequence right. Any other questions?
Did you mention HDPE?
I did not. For Chucks or for?
Yeah, I've got some of that 1-inch thick HDPE as my base instead of wood.
Right.
It works for two good reasons. You can cut a groove in it and put your PVC pipe in it. It creates a good seal, and you can tap it with a thread. It's very easy to cut a 1 1/4 tap with it.
Yep. No, that's good. That's a good point. Yeah, there's a number. I think Holdfast actually makes some plastic. I think if you buy the Holdfast vacuum chucks, that they are HDPE. I think they construct them entirely of it. So the other thing you can do with HDPE is you can turn them. Like I use some for making for holding pendants. You can actually turn it a little concave surface on it in order to hold the pendant. So yeah, no, that's good. I haven't done that, Norm, but that's a good idea.
Yeah, Steve, Holdfast has a aluminum collar, I guess you would call it. Then it goes to the plastic or the HDC or whatever it is.
Right.
And then it has a foam ring. It actually has 2 foam rings on the end of it. So, but I've experienced problems with that if it doesn't have a really good seal, or if the foam is not connected to the wood piece strong enough, the outside rim hits the bowl and it spins a little bit, it leaves a mark on the inside of your bowl, where your method where you're wrapping that foam around the edge of it prevents that from happening.
Right. And I have to tell you that I have homemade vacuum chucks that I use for various applications, but that 6-inch one-way is a beast. It is a rock solid, and it doesn't. There's no vibration. There's no deflection. It is. I use that about 90% of the time that I work, and it's. Again, it's $100, or $130, whatever it is. But it is. I've had that for 10 years. It's never going to wear out. There's no mechanical parts in it, and it's really a welcome addition to the process.
Excuse me, the Holdfast one is the one with the lamp rod and the black plastic foam for do-it-yourself?
Well, the lamp rod, the Holdfast. The lamp rod's on an adapter that gets you through the headstock.
Yeah.
They also make a chuck, that's the one that has the foam on it. So that's a separate piece.
And I got one of those, and it comes as a kit with extra with black foam. And I've had that same black foam problem, that if the workpiece spins just a little bit, it leaves a really nasty mark. But I also ran into an issue where I was using a plastic vacuum hose from the pump to that connector, and after putting it on and off half a dozen times, it just kind of expanded a little bit and it would fall off. And if it falls off while the lathe is running, you have a really nasty situation. But I cured that very easily with a 1/4-inch screw type hose clamp, so it doesn't go anywhere anymore. So that's another suggestion for, if you use that kind of connection to that kind of hose, it can get loose. So, do a little precaution there to make sure it doesn't fall off in the middle of turning. I
would strongly recommend that you use the nylon hose with compression fittings. I know the hose you're talking about. That nylon hose with compression fittings, the fittings are cheap, the hose is cheap, and you're not depending upon a friction fit on there. It's a screw connection, and again, as Alan said, you do not want this thing to let go on you. And the problem is that also, even if you just have a little bit of leakage, when you get into, if your piece is a little bit porous, especially, you get these thin wall pieces, you can get a little leakage. It's hard to maintain that vacuum. And so any place you can get a better seal, the better off you are in doing it. And it again, you just don't want it to come off. So
True with spalted wood and some with tiny little wormholes you didn't know were there before.
yeah. So
Yep, you're right.
all
Another
right.
thing that'll come up, times a crack that's sealed normal, put it on the vacuum, it'll open up enough, you can hear the pump or change sound. And whenever I hear it change sound, that's a warning sign to stop and figure out what's going on.
Yeah, and that's why it's important to have a gauge. I mean, when I have a piece in the vacuum chuck, I am always looking at that gauge to check it. And again, it's certainly, Preston, like you said, if there's any changes in sound or vibration, I mean, you always just you got to be able to look at that gauge and make sure that it's there and you can see what's going on. So
Yeah.
All of this-
HPT, I think the Trex artificial would be a similar product that would be easy to thread as well as wouldn't change on you.
I think it's a little more likely to have some air passage, though. It's not as dense.
Okay,
Be careful, I'm just saying.
sure. One of the things, when I was making mine with the PVC, I would cut it as straight as I could and then glue it into the wood or whatever. And then I would turn the lathe on and I would notice that it didn't seem true. So I would actually turn the PVC to get it running smooth before I put the foam on it.
right. So in part 2, I'm going to actually go through how to some tips on how to make your own vacuum chucks.
Okay. All right, sorry.
All right. So let's go ahead and
Let's talk about the various options you have for vacuum pumps. The vacuum is really the heart of your vacuum chucking system. As we mentioned, in addition to using a vacuum pump, you can use a vacuum generator that's connected to your compressor. But I'm going to talk about the various types of vacuum pumps that you can use and the advantages and disadvantages for each. So the first one is these small pumps that you typically see used for HVAC applications. This is the pump that I use for my vacuum stabilization chamber. It's an oil bath pump. It's got a eccentric cam in there that's embedded with oil. It's only 1/10 of a horsepower. It doesn't provide much volume of air, but it provides a very high vacuum. That works great for vacuum stabilization where you're not moving a lot of air, but it doesn't work very well for a vacuum chuck system where you may have to move a higher volume of air. If you're using porous, if your wood is porous or a little bit punky or you don't have a good seal, it's really important with a vacuum chucking system that you be able to move a high volume of air while maintaining that vacuum. Whether you get an additional inch of mercury as when you to 25 versus 27 inches of mercury when you're pulling your vacuum probably isn't as important in a vacuum chucking system as it is to make sure you get enough volume to maintain that. So that's the simplest one, again, but not really applicable for, in my opinion, for a vacuum chucking system. The next option that you often see, this is a diaphragm vacuum pump. The advantage is they're relatively quiet, reliable, maintenance-free. There's no oil involved. A lot of times you will see them where there are two chambers, two diaphragms involved, and that tends to smooth out. The way this works is there's a cam in here that moves a rubber diaphragm back and forth, and as it pulls air in and pushes it out, it creates the vacuum. Well, if you only have one chamber on a diaphragm pump, the vacuum tends to pulse a little bit. Not the best system if you're trying to hold a strong vacuum on a piece of work. So often they'll use 2 chambers on the diaphragm pump, and they're out of phase, so that tends to reduce some of the pulsing on the system, and they just get tied together when you put this on. Certainly a workable system for a vacuum chuck if it can move enough air. It will not provide, typically, it will move volume of air. It doesn't quite move as much, it doesn't provide as much vacuum as some of the rotary vane systems, which we'll talk about. But that certainly is an option. It's an acceptable option, and you can usually find these pumps used. The next type of pump, and this is the type of pump that I use, is a rotary vane pump. And you'll notice that when I mentioned the Frugal Vacuum Chuck website and supplier, they used to carry diaphragm pumps in their systems. I saw recently they just switched over to the rotary vane pumps. These are what's used in most industrial type applications. And the way these work, I have one here that I will, I'm just going to open up the end of it here for you so you can see. It's actually a very simple system. As you can see, and you can zoom right into this, that there are 4 vanes in here that come out, and these vanes just operate on centrifugal force. And as the pump spins, the vanes come out and are forced out. The air comes in on this side, it's pulled in. If you're compressing an air, these can actually use it for compressed air or a vacuum. It pulls it in, and again, as it changes shape through the system here, this eccentricity will either compress or pull in air in a vacuum. They're very reliable. Again, a lot of medical applications, dentist office, industrial applications that require a continuously running pump will often use these rotary vane pumps. Now, the rotary vane pumps come in two different ways. This particular one is a dry pump, and the difference is, and then there's an oil lubricated pump, and the difference is these vanes. So in a dry pump, the vane is made of it's carbon graphite, and it's kind of self-lubricating. In a oil lubricated pump, you'll see that the let's see if I can get these together here. The vanes are made of a phenolic plastic, and that requires oil in the pump to lubricate it. Now, it's not an oil bath, it's just a little bit of oil that comes in that gets brought into the pump, and I'll show you one of those pumps here in a second. But the advantage of the oil operated pump is that in an industrial application, these carbon vanes, or the graphite vanes, eventually wear out and do require replacement because there is no lubrication. The phenolic vanes will last longer, and you get a little bit higher vacuum because you got an oil film on the inside of your pump here that creates a little bit better seal than the graphite vanes. So for a woodworking application using vacuum chucks, there's absolutely no reason why you need to go with an oil lubricated pump. It's another thing to take care of. The carbon vanes work fine. They give you plenty of vacuum, plenty of air volume, and for the amount of time that most of us will be using this vacuum pump, they operate just fine in our systems, in the system. So if you do go with an oil pump, and a lot of times the decision to go with an oil pump versus a dry pump is just what pump you get. And some of them you can actually switch the vanes in there. These are both gassed pumps made by gas manufacturing, and some pumps you can switch between wet and dry. The first pump we showed you here, the first rotary vane, is only a dry pump. So sometimes you can switch the vanes, sometimes you can't. So if you have an oil one that requires an oil lubrication, if you're using the phenolic vanes, you need to have. You'll see right here. This is how it's oiled. There's just a little as the air comes into the system, there's a little wick inside this jar. There's vacuum oil in here, and it just provides a very fine mist inside the pump, and it lubricates it as the air goes in. And then with either one of these pumps, with the rotary vane, it's actually a good idea to put an exhaust filter on, so that certainly with the oil, because you will get a little bit of oil mist coming out. With the carbon vanes, you do get a little bit of just a little bit of graphite coming out of the well. It also tends to be a bit of a muffler if you put these exhaust filters on, and so in addition to cleaning the air as it comes out, it does make the pump run quieter. With either one of these pumps, as I mentioned when we talked about the first part of this demonstration, you want to filter on the inlet side, because you can see that if you were to pull sawdust into this pump, if you were to get sawdust down into here and you have these vanes running around, it's gonna damage your vanes, and the pump is going to cause it to wear out very quickly. So you want to filter your inlet air, so it's not a problem. The same thing would happen with the diaphragm pumps. With the HVAC pumps, probably not as much of a problem, because those require, the maintenance on those is they require you to change the oil a little more often. So it's important to put a filter on the inlet side. This one doesn't have a dust filter before this. There's actually a filter built into the oiler. On the one I have permanently attached for my lathe, I do have a second filter in front of this. It's just a paper cartridge filter that filters out dust before it gets to the oiler. Just a quick review of the plumbing that we talked about. This is a little bit more visible. So this is the vacuum side, the inlet side of the pump. So the vacuum comes through this hose, comes up to a gauge. And again, we talked about, this is just a bleed valve that you can open and close to release some of the vacuum. And again, depending upon the size of the pump that you're using, you may want to reduce the vacuum a little bit, but it's important to have a gauge that you know where you are, and then the bleed valve that allows you to adjust it. And then this hose would go down to your quick connect onto your adapter on your lathe. From a maintenance standpoint, very little maintenance is required for the amount of time that you're using any of these pumps, except for the HVAC pump. But really, for these particular pumps, just cleaning out, making sure if you're using the filter on the inlet, making sure you get that cleaned out. The advantage of these pumps is they're very easy to, if you should see a degradation of your vacuum, most likely the problem is that you have there is some debris on the inside that you probably should clean out. So just popping 6 screws off the end, take it apart, you take the end of it off. It just comes off with these 6 bolts. You take it out, you just clean it, make sure that there's no scoring, and you can buy replacement. If you're using the carbon vanes, you can replace the carbon vanes. They're available for all these pumps. You can replace the vanes if you need to, but usually just cleaning out the inside if you should get any dust or anything there. That's usually all you need to do. And again, these are meant for high volume, high running time applications. So the amount of time that we're using it in our shops for vacuum chucking typically isn't a problem. I often get asked how much airflow do I need for a vacuum system, and it's it's hard to answer that question because it depends on the type of work you do. It also depends on you have to look at pump curves. There are pumps that will give you very high vacuum, but not very much airflow. And there's other pumps that will give you a lot of airflow, but not very much vacuum. I find that the rotary vane pumps are a good compromise. The oiled ones give you a little bit more vacuum, but these are about the same from an air volume movement. They're very reliable and very consistent. I would say something in the range of a 1/3 horsepower is probably as small as you want to go for a vacuum pump for a vacuum chucking application. Less than that, that you may not get the volume or the vacuum that you need for this. The other thing to look at is your motors. Both these pumps have what's called a totally enclosed fan-cooled motor, and so that means there's no dust going into the motor. They're fan-cooled, but the dust doesn't get into the motor with the fan. The air goes around the windings of the motors. You're not getting dust in there. So that's something you look for in your motor. And you also might want to look for the rating on the motor to see whether it's continuously rated to run continuous. Typically, if you have your piece on the vacuum chuck, you're not going to want to turn it off. You don't want your pump overheating on you. So just make sure that it's a real advantage to have something that's rated for continuous operation, and you'll find that on the nameplate of the motor. It'll say whether it's rated for continuous operation. Motors that are not rated for continuous operation that are rated for intermittent operation, it's typically they'll run for about 10 minutes and then they should cool for at least 10 minutes on a lot of the motors you look at. So again, 10 minutes typically isn't going to be enough if you're trying to finish the bottom of a larger piece, or you're using it for a finishing application, or some of the things I talked about when with the acrylic discs and stuff like that. So anyway, that's just a quick overview on pumps, and next we're going to look at how we fabricate some vacuum chucks and the applications on the lathe. All right, so after we talked about the vacuum pumps, I'd like to just show you how you can construct your own homemade vacuum chuck. So just talk about the parts you need. You either need to thread you need a block of wood to start with. Either put a faceplate on it or thread it. And it's better to start with something you can either leave on here, because if you take faceplates on and off, they tend to, it's hard to get them recentered. So it's important that they stay centered. I just screwed a faceplate on here. That'll go on there. I use PVC pipe, and this is 4-inch. This is for making a 4-inch piece. Now, you can just use a piece of 4-inch PVC pipe, about 6 inches long, and do it. But you'll notice, particularly when you get up into the larger pipe sizes, that it's not solid, rigid PVC. That the inner core of these is almost a foam. So I'm not comfortable with that, just using that as a vacuum chuck, particularly if you're going to use bigger pieces. So what I've done is I've taken a 4-inch coupling and I've cut pieces that fit inside this, and I'll put it on both sides, and I'll just glue it in with PVC cement, and it just gives me a double wall thickness, and the coupling itself is much stronger. It's solid PVC versus what the pipe is. So we'll go ahead and glue those together. So those pieces, and then you finally need a gasket to put on that when you're done. So the process is I'm going to first glue. This is PVC cement. I'm just going to take this and glue these pieces in to the coupling. the same thing on the other side. We'll just give that just a second to set up there. And so you can see that you have a double wall thickness on here, on this. You got the pipe and the coupling. I'm going to take, this side isn't quite flush with the front. This side is, the two surfaces are very flush. I'm going to use this to mate onto my, onto the wooden block here. I've cut the tenon on here about 5/8 of an inch thick, 5/8, 3/4, somewhere in that range, and you want it to fit pretty snugly because you're depending upon that tenon to give this the strength that it needs to function. And you'll see that if all this still fits on here, that is a snug fit that goes on there. All right, so what I'm going to do is actually just take this off for a moment. I'm going to mix up some 5-minute epoxy and glue that on. Typically I'll use 5-minute epoxy to get an initial glue on there. If I need to, if I find that it's leaking, I'll go ahead and just put a layer of silicone on the inside ribbon there. So the epoxy, really the purpose of the epoxy is to just hold this on here. So we'll go ahead and get that mixed up. Glue. And I'm just going to go ahead and get that pressed on there. And I'm just going to put this back on the lathe here, just because I'm going to use the tailstock for a clamp to hold that on, because it's important that you get that on square. And so I'm just using the tailstock to apply some pressure on this to make sure that it's square up against this shoulder here. If you're using smaller PVC, if you're going to do this with 3-inch, you can actually make the pipe fit down into it. You can cut a groove instead of just a mortise or a tenon on there. With as big as this is, I did not cut a groove in it just to keep the size of the block down. The other thing that I do on this, just to, again, this is a piece of 4-inch PVC. It could have a pretty significant bowl on there or blank on there. I like to put a couple of screws in there just to hold it in, a little bit of security. And again, the screws aren't going to hold it together, but they will. If you can keep this whole thing from loosening up, it's just a better system. So what I do is I'm just going to drill a couple of holes in here. Through the PVC. And then just drive a couple of pan head sheet metal screws in here. Again, you want to use make sure you use a screw in there that's got a round head on it, so it doesn't, if your hand should hit it, and you wouldn't want to use a hex screw or something like that in there, because that might cut your hand. So again, just So what we're going to do is come back in a few minutes after this glue sets. We're just going to true up this surface, and then it'll be ready to use. There is one more step that we'll do also later. We do have to drill a hole through the middle of it in order to get the vacuum into the chuck. But we need to let that epoxy sit up for a little while before we come back. So the glue's set up on this, the homemade vacuum chuck here that we made. Again, 4-inch PVC coupling and PVC pipe in here. So as you can see that there is a slight taper on the coupling, so you don't get a smooth surface right off the bat with the pipe. So what I'm going to do is I'm just going to turn this. And the other thing you find a lot of times that you know, these aren't perfectly round because it's PVC pipe and it doesn't really matter, or they're not concentric is more often the case. They may be round, but they're not centered. So it's important to have a square edge on here to start with, but even with that, sometimes you still have to work on getting this round. So all I'm going to do is I'm just going to turn this round. I'm going to take a little bit off this top surface here to get, and you can manipulate this any way you want. As we said earlier, if you're doing something like a small vase that's going to fit in here, you may want to taper on the inside. If you're doing something that's going to fit like a bowl that's going to come over the outside, I'm just going to put a rounded edge on here for now, and then I'll leave this so I can shape it as I need it in the future. So we'll go ahead and turn it. You can see that the coupling is actually more brittle than the pipe. And we've got a little bit too aggressive in there, but I'm going to go ahead and take this and just round this edge over a little bit. And but it's almost flat there. I've gotten rid of the taper on the coupling. And so I'll just take this one more time and just get that smoothed out and rounded out, and we'll call it good. So that's what I did. I've rounded the top and the bottom just a little bit, put a little bit of taper on it. And as with turning any plastic, you need to use sharp tools and you need to give it time to cut. And what I did when that chipped out at the beginning, it was just I was pushed it a little bit too hard, did not give the plastic enough time to cut. And particularly with a brittle plastic, it'll just it'll chip out on you. So after that, now I would just take, I'm not going to do this now because I'm going to leave this to shape and some other application, but I would just take this peel and stick, and again, it's just a peel and stick piece of foam, put that on there, and I'll do that whatever, use it however I need it to be. So anyway, cheap homemade vacuum chuck. It's the coupling is $2.50, and a 2-foot piece of pipe was $6. Probably have the block of wood in your shop, so for about $10 you can do this. If you're going to leave a faceplate on it, or you'll have to pay for that. But if you thread it, which is actually a pretty good way of doing it, using a Beal tap based on your lathe, you can do it that way as well. It works very well. There is one last step on here, which I don't need to show you, but you do have to drill a hole through the middle of this wood block in order to get the get the vacuum through it. So that's the last step. So that's how to make your homemade chuck. All right, so we've gone through pretty much the whole system now, the parts, the components, the pumps, the chucks. So just like now to close by just showing you how I go through the process of using the vacuum chucks on the system. Right now I'm not going to use it, there's no vacuum applied to this, so I'm just going to use it as a jam chuck to kind of hold this this is a rough turn bowl. It's got a small tenon on it, and I'm just going to true up this tenon and get this ready to finish turning the inside. I'll eventually be mounting this on a chuck to turn it around and finish the inside. So I just find that these the vacuum chucks are just a convenient way to hold a rough turn piece back on it, because it's got that the rubber surface on it gives it a pretty good grip. It's important that when you rough turn your pieces that you leave a center point on there so you can come back and recenter them. If you don't, you can if you forget to do that, you can always come back and just estimate it or try to put a gauge on it. But you can see this is quite oval at this point. So just going to take this, line it up with the center point on my tailstock, bring it up against the chuck, and then just apply some pressure. And I always lock my tailstock in at that point, because the only thing that's holding this on at this point is the pressure of the tailstock on there. And if you should have your hand wheel in a position where it could, the weight of just the handle could, the vibration could make it loosen, and the bowl can come flying off. So what I'm going to do now here is I'm going to true up the tenon and just give the outside just a real quick shake. Obviously that would need a little bit more work. I'm not going to spend the time on it here to do that, but the purpose is to get this tenon, to give you a means to get this tenon shaped, so you can now put it in a chuck, turn it around, obviously I finished cleaning up the outside, but put it in here, turn it around, and finish up the inside. Alright, so we've taken this, we've taken this off the chuck. We've had the inside completely done, the outside done, and through the magic of television, we're going to end up with something like this. And so now we're going to use the vacuum chuck to finish this foot. So got a center point marked on here, and I'm just going to line that up with the tailstock, slide it up against the vacuum chuck. And I'd like to go through, give it a spin, make sure it's centered. If not, adjust it as necessary. Again, put a little bit of pressure from the tailstock on. I have the adapter for the vacuum system into the hand wheel, and I will then take this, connect it to the vacuum pump. And before I turn it on, I'm just going to make sure that, again, at some point I'm going to take this tailstock off, so the vacuum chuck is going to be holding this on its own. So I want to make sure that everything is aligned, it's spinning freely, and I'll turn on the pump and make sure that on my vacuum gauge that I do have sufficient vacuum. And the other thing to be aware of is as you cut this with your gouge, you want to make sure that that you take small cuts. Again, it's being held on by a vacuum, that the cuts are small, and you want as much as possible for the cuts to be into the wood rather than lateral, or into the bottom of the bowl rather than lateral. So with that, let's give this a shot. So I have 20 inches of mercury on the vacuum, which is a pretty good vacuum. It's being held on with several hundred pounds of force at this point. And so I can actually take my tailstock off and give it a tug, and it's on there pretty good. So I'm going to go ahead and finish this. And that's the process. Turn the vacuum pump off just so you can hear me, but I've smoothed out the transition from the chuck. I would probably, depending upon the thickness I had, make that a little bit deeper in there to smooth out. And then I just did a shear scrape. No matter how well you try to get this centered, it's never exactly right. So when you do your foot, you need to just try to leave yourself enough room. But I just did that small shear scrape to bring that the edge of this foot back into the sides of the bowl, and that just that little transition, it just smoothed it right out. And then I would obviously just take sandpaper and finish sanding this and do it. So a couple other things I just want to mention in here that you can do very often. After I often use Seal-A-Cell oil finish on my pieces, and I'll just give them a coat of Seal-A-Cell, let them set up, and after the Seal-A-Cell's on there, I often will come back and give it just a very fine sanding, usually with a white Scotch-Brite pad or with 600 sandpaper, just to smooth out the nibs or anything that end grain did. And the way I do that is I just come back to the vacuum chuck, and all I do is I just spin it, and I just do this by eye, and I just hold it and until it gets, because I no longer have a center point on there, so I'll just center this by eye on here, and then turn on the vacuum. Very well, so you can see it's certainly well centered enough at this point to come in and to take my Scotch-Brite pads or whatever I want to do. If there's a piece I need to work on there, I can just take it. And I just do this at very slow speed. But you can see how well that is centered. Just doing it by eye, holding it on there before I do it. And then often I will just take this and do the same thing, just come back here, turn it around this way, Um, and again, I'll take my Scotch-Brite pad in here and just go ahead on the inside and turn it and smooth it out. A couple of things that I have used this for. I recently did a set of coasters for a gift, and I had a whole bunch of them. I've used this just a flat chuck like this. I had a piece of foam on it, and you can see that this one has the threads on it. And I just had this threaded on. I used a vacuum chuck that held them on there. I had a center point on it, and it just gave me, because they were so thin, I didn't want to use something like this because I was worried that it would distort it as it sucked it in. So I had a flat surface here with a foam pad and just slightly convex or concave to give it some surface area to grip to. And I didn't need much. I just needed it to finish the bottom, just get it flat. And that worked fine. I've also used something like this for pendants. Again, just so this is a piece that I've used. It started out thicker, but I've used it for several odd things that I want to do. But if it's an odd piece that I want to apply vacuum to, I just modify the shape of this, stick a piece of foam on it, and I can use it as a vacuum chuck. So. I hope this was helpful. So all the ways, or many of the ways that I use a vacuum chuck, as I said in the beginning, I find this an indispensable part of my turning equipment. I use it, I have it set up, it's convenient to use, and I use it all the time, whether it's for finishing or for just finishing bottoms of bowls, or for, as I showed, when I turn pieces that have no other way of even holding them, this works very well. The one time it doesn't, if you have some really porous punky wood, you just have to make sure you have a pump that's big enough to apply enough vacuum to get it on there. And you just need to be careful when you do it, realizing that it is a vacuum that's holding it on there. There's no other mechanical means. So you want to make sure that you are gentle with your cuts, and you're certainly standing out of the line of fire as you have the pieces coming around. All right, with that, we'll conclude this. Thank you very much.
All right.
Wow, great job, Steve.
Thank you. Any questions?
Yeah, I had an aha moment when you made the walls double thick. Because I've just been using, I think, one level of PVC, and it seems like it's too sharp where it touches the wood and can make an indentation.
Yep.
Yeah.
And it's particularly if you're using the pipe, which is foam. I mean, the coupling is thin. It's very thin. The pipe, when you get up to 4-inch Schedule 40, is foam filled. And I've seen it flex, and so I'm just not comfortable with it. So I found that to be very successful to get the double wall.
One of the questions that came up in the chat a couple times, Steve, was how much vacuum is sufficient, or how do you adjust that vacuum essentially for different pieces?
So it's hard to say how much is enough. It depends on the size. So a 6-inch chuck will certainly give you, it's a function of the surface area of the inside of the chuck, which is, you can calculate the force. And it's the weight of the piece. I mean, there are some of these lightweight burl pieces that I do that are so porous that I might only have 15 or 16 inches of mercury on it. And that's not a lot. So you just have to but all I need to do is just finish that final foot. If I'm turning a heavy bowl, I'm looking to get, 20, 22, 23 on that 6-inch chuck. So you really can't say how much is enough. It depends on what you're doing. And, but if it's a heavy piece, it's a combination of it. So you can get by with a little bit lower vacuum if your chuck is bigger, because it's a function of both the pressure or the suction and the surface area. So you need the two combined will give you the amount of force you have on it. So if you can go with a bigger chuck, you're always better off going to it. That's why I use that. If I can use it, I use that 6-inch one way.
There's a really simple test. With the lathe off, you try to pull it away. And if you can't pry it away, can you bang on it from the side with your hand? Nothing's going to do any damage to the piece. And if it's going to slide, you haven't got enough grip to it.
Right. Yep. Any other questions? And the other question that I get, that I've heard, is that, how much pumps, vacuum pumps have a rating to them of how much airflow. And they say, well, how much airflow do you need? Well, it depends. It's a combination of the two. But if you're going to buy a pump, all pumps have a rating as to the maximum vacuum that they will pull. And some of the smaller diaphragm pumps, I mean, the maximum they're going to pull is 20 inches of mercury. That's not very much, because if that's the most they're going to do, they may pull a very high volume, but if the seals in there are not sufficient to give you a high enough vacuum, they're not going to do the job for you.
Do you get enough distance when you're using natural edge bowls with your lathe, or do you use an extension? I know Holdfast has a extension to avoid hitting the edges of your natural edge bowls, or do you have some trick that you use to?
Well, so you can make a longer chuck.
Longer pipe.
Yeah, just longer pipe, but again, you got to be careful with that 4-inch PVC, because it will start to flex on you at some distance. So the
anchor-based and somewhat solitary anchor, but I don't see this thing mushrooming the way it could have if we didn't get under control.
I think
Jerry,
we're getting background.
It was Jerry. I muted him.
Okay. But what I found, one of the nice things about the Robust is the headstock has a, comes out, there's a space, there's about 3 inches there that you get on that. And then plus that one-way chuck is almost 6 inches deep. So, you got a pretty fair amount there to work with. I haven't had a problem with things that I've worked on that not having enough. And I do have a deeper PVC chuck that I've used a couple of times to take care of that. Any other questions? I do have, I'm going to share my screen one more time. I just have a couple quick pictures. It's not in the video, but I just used it, an application. I just used it just the other day.
This is our new homepage.
Let me just go to here. So this is a hybrid bowl. It's burl and resin. It is about 14 inches in diameter, and I cored it. It's actually the first time I ever cored this stuff. But and after I cored, I realized I hadn't put any means on the top there to hold it with the inner core. That's what it looked like. So I put my vacuum chuck on. I did have a center point on the top. So I just, I put it on. I held it on with the vacuum. I used that vacuum chuck to hold it well enough to just drill a hole in it so I could mount it on a chuck. Mount it on the chuck so that, I mean, the object was I did another core on this, but I needed to be able to turn a foot on it, and then ended up turning a foot to hold it in the chuck so I could do the next core. So again, just a my point is that there's applications that, when you're sitting there, just question how you're going to hold something. It's very often that the vacuum chuck will do it. But as I said in the video, one of the keys to making that work is if you have to do a whole lot of setup every time you want to use your vacuum chuck, you'll find excuses not to use it. What I found was having the system set up, ready to go. And when I was using that adapter with the lamp rod in it, there's a lot of times if I didn't need to have that out, I would just leave that in the lathe all the time. And so it was ready to go. Now that I had the adapter for the hand wheel, it's faster to put that in. But the fact that the system is set up ready to go makes it more convenient to use, and therefore I use it more often. Any other questions?
I use a refrigeration compressor, which will suck down to probably about 18 inches, but not with volume. So you've got to have a really good seal.
Right.
The first 11 times I used it, I think, I figured out that almost all wood has wormholes.
Yeah.
And when things work great until you suck the worm poop out of the wormhole, and then the thing comes off in your hand.
Yeah.
So you gotta watch real close what's in the wood and what can happen, because you can be half done with the thing and all of a sudden it comes off.
Yep. It's a very depressing time when
Yes.
when it comes off, and that's why the reliability of the pump is just so vital. Is again, you just don't. If you have a pump, we talked about the duty rating on the pump. Some of these the lower duty rating pumps that are meant for intermittent use. If you're doing something like those hybrid discs that I do, it'll be 30 to 40 minutes that I'm working with that vacuum pump on. And if you have a pump that's not rated for that, it probably has thermal protection. It'll shut off by itself when before it burns itself up. And yeah, you just don't want that happen when you have a 20 or 30 pound piece of work on there, particularly when not only the cost of the equipment or the material, but the amount of time you have in it, because it's always the last thing you're going to be doing on the piece. So a reliable pump really is the key to it.
Hey, Steve, do you ever see a difference when you're finished turning a wet piece? Do you ever see a difference in the holding power?
John, a lot of it depends on the thickness and the type of wood. But I haven't seen, the one thing you have to be careful is that you can actually suck moisture out of the piece, and it'll get into your pump. So that's one thing to consider. But I haven't seen a difference really in the holding power. If anything, it probably holds better when it's wet, just because the pores are somewhat filled with moisture rather than air. So,
I had a problem once with a wet piece that I was vacuuming, just because it was starting to dry, so it started to warp. It was harder to get the seal because the edges were, over 20 minutes moving a little bit.
Yep. Any other questions?
I just wanted to mention the Hdpe. I posted a link to it. This is 1 inch thick. It looks like it's lower because I cut a groove into the side. This is a 1/2 inch thick pipe, the coupling pipe, PVC hot glue, and a Beal tap. No air leakage at all from this puppy. That's the nice thing about Hdpe. It's not going to sieve air like wood would.
Yep, that's a good point. All right. So that's it for our demo tonight.